NASA's giant spacecraft ear a crucial antenna breaks, delaying asteroid research and raising concerns about future missions for almost 2 months. NASA has been battling communication blackouts with its spacecraft, a consequence of a major breakdown in one of its most vital tools, the Deep Space Network, DSN. Specifically, the problem lies with the agency's historic 230-foot-wide radio antenna near Barstow, California, nicknamed the Mars antenna for its role in receiving signals from robotic probes exploring the red planet. This behemoth, roughly the size of a Boeing 747 jet, malfunctioned on September 16th when it over-rotated during operations, stressing internal cables and pipes. Flooding caused by damaged fire suppression system hoses further compounded the damage, though this water damage was quickly contained. While NASA has established an investigation board to pinpoint the exact cause, the antenna remains offline as engineers assess the extent of the damage and plan repairs. The timing couldn't be worse. With a federal government shutdown in place, communication with NASA personnel was severely hampered for weeks, leaving questions unanswered. The repair timeline remains shrouded in uncertainty, raising anxiety about how this outage might impact future missions, particularly Artemis II. This ambitious project aims to send astronauts around the moon as early as next year. Artemis I, its precursor, relied on over 900 hours of DSN support in 2022 and even experienced brief communication blackouts during flight, starkly illustrating the fragility of this vital system. A global lifeline for spacecraft communication, the Deep Space Network is a global marvel, boasting 3 antenna complexes strategically placed across California, Spain, and Australia. This network operates around the clock to ensure continuous contact with spacecraft orbiting Earth or venturing further into our solar system. It's responsible for commanding and monitoring over 40 ongoing missions, with many more on the horizon. Its importance cannot be overstated. As Al Banji, a former DSN manager, stated during its 50th anniversary in 2013, "Without the DSN, we would never have been able to undertake voyages to Mercury and Venus, visit asteroids and comets. We'd never have seen the stunning images of robots on Mars or close-up views of the majestic rings of Saturn." A system under strain, the aging infrastructure is facing mounting pressure. NASA's own Inspector General has repeatedly called for upgrades to address an increasing data load that has skyrocketed by 40% since the system was built 3 decades ago. Despite ongoing efforts, including a program to add 6 new antennas, with a new 112-foot-wide dish slated for California in 2026, the DSN remains stretched thin. The damaged Mars antenna itself plays a critical role beyond routine spacecraft communication. As the world's most sensitive planetary radar, it scans near-Earth asteroids. This pinging technique allows scientists to pinpoint their positions, velocities, and trajectories, crucial for identifying potential threats to our planet. Radar imagery can also reveal vital details about an asteroid's physical characteristics, supplementing data gathered through optical telescopes. The Mars antenna assumed even greater importance after the devastating collapse of the Arecibo Observatory in Puerto Rico in 2020. Since then, it has detected over 200 near-Earth asteroids, with more than half classified as potentially hazardous. The antenna's absence will severely hamper these crucial observations at least through the end of this year. The good news is that NASA maintains a resilient and redundant system. While repairs to the Mars antenna are underway, other DSN antennas can still support some critical missions. However, the incident highlights both the vital importance and inherent vulnerability of this infrastructure. As we embark on ambitious new space exploration endeavors, ensuring the health and resilience of the Deep Space Network will become ever more paramount.